All right. I think that's recording. Yeah. Okay, so chapter 3 is titled Graphing Linear Equations. Hey, we've done linear equations, haven't we? Graphing linear equations in two variables. Now that's new, okay? That's new. When we were doing linear equations for this past test and all the things that we have been doing up to this point, I had been stressing to you that we had linear equations, right? Linear equations, kept on saying it to you. But then I also said, we'll say linear equations in one variable. The reason why I did that is because I wanted you to see the distinction now that we have two variables instead of one. So let me first give you an idea of where we're headed with this chapter, okay? What we're going to have here eventually is a graph, and we're going to spend time on this. It's going to be something like this. It's going to be a drawing, basically, that we make on a piece of paper, and the drawing is going to be of a line. So somehow I'm going to start by giving you a linear equation that has two variables in it, and you're going to wind up drawing me a line. That's going to be our goal. All right? But before we can start drawing lines, we have to first make sure everybody is comfortable with what's called the rectangular coordinate system. So that's where we begin, and that's what the first section is about. The rectangular coordinate system. So now we are actually in the first section of this, chapter, 3.1. So the rectangular coordinate system. What we have is, if you look at a flat sheet of paper and you draw this cross through it like this, then we call that the rectangular coordinate system. Normally we label this horizontal line is left to right, horizontal, right? The vertical is up and down. The horizontal line, we like to call it an axis, and we call it the x-axis. The vertical line is called the y-axis. Now, if we do this, then you can look at any flat surface, you can draw a cross on it, and then you create these axes, right? Then if you do that, you actually break up this flat sheet of paper into 4 different sections, don't you? You have top left, top right, bottom left, bottom right. Well, since there are 4 sections, 4 regions, we call each of them quadrants. And so quad meaning 4. And so we label each of these quadrants. Now, the way we label it is not what you would normally want to think. You would think top left would be the first quadrant, right? And then maybe read it to the right in quadrant 2 and then 3 and 4. That's not the way it goes. It actually goes, I'm going to call it Q1. That means quadrant. Quadrant 1. Q1 is there. Q2 is here. Q3 is here. I'm using Roman numerals. And Q4 is here. Now you might be asking yourself, why in the hell is it labeled like that instead of 1, 2, 3, 4? And that answer actually the answer to that comes from pre-calculus or trigonometry, a course beyond this one. And it just has to do with the fact that when we measure angles, we always start pointing out the right, and as you measure an angle, you go counterclockwise like this. Okay, that's the way we measure angles. So if you're measuring an angle and the angle's getting bigger, then you want to naturally pass through the first quadrant, then the second quadrant, then the third, then the fourth. You don't want to be like in the second, then the first, then the third. You know what I'm saying? You want it to follow that numerical order. So that's why we label it 1, 2, 3, 4 backwards. Y'all follow that? Okay. We don't need to really know anything about angles. We just need to know that's the way it's labeled. Okay. Now each of these axes, the x and the y axes, is a number line. You know, each one is its own number line. So if I go to that x-axis, right here at the center is 0. Then to the right, we can label 1 unit, 2 units, 3 units, and I keep going. To the left, we have negative numbers. And it keeps going. And then on the y-axis, it's the same thing, but it's up and down instead of left and right. So for the y-axis, up is positive, and down is negative. So imagine just, you know, the number line that you grew up with, right? That's the number line you grew up with, 0 and then each direction forever. Just take one of those and lay it on you know, flat. That's your x-axis. Take another one, turn it, and put it up and down like this, and that's another axis. One of them is called x, one of them is called y. But it's just two number lines crossing each other. Now, there's an important point here. Anybody know what that point right in the center is called? The origin. It's the origin. Now, the reason why we use this rectangular coordinate system is to help us be able to visually understand answers to equations, as we'll see later. But to do that, we have to understand how we can actually put things on this rectangular coordinate system, how we can actually plot things like points and lines and different curves. So the book doesn't refer to this, so I'm going to put this up here. And you'll hear me say this in class. This is what I'm referring to, all right? Remember this script R? Remember that? Script R, top right. I just put it up there. See it? Script R. What did that mean again? All real numbers. Isn't all real numbers a number line? Every real number is really a full number line, isn't it? Well, if I put R, script R, with a little 2 above it like that, in the top right, like an exponent, that means we say it R2, okay, R2. R2 is 2 number lines crossing each other, which is basically the rectangular coordinate system. So from here on out, if you hear me saying R2, oh, we're going to graph some points in R2. I'm talking about we're going to graph some points on a rectangular coordinate system. Is that fair? Everyone understands what I mean by that now? Okay, so now what I'm going to do is I'm going to get a new sheet of paper, and I'm going to ask us to graph some points, and I'm going to give you some more language here. I realize a lot of you have seen this before, so bear with me. Now I'm going to cheat a little bit, okay, because my computer allows me to do that. I know you don't have graph paper necessarily, and you don't need graph paper. So I'm going to put here as an example, I would like for us to plot on this the point -2, 5. And I'm going to put next to this, this is a point. And actually, the first number you see is the x, and the second number you see is the y. So let's just see how we would do this. And it will always be that way, okay? If someone gives you a point to plot, the first number you see is the x, the second number is the y. I'll have a technical name for that in just a minute. So first I'm going to draw my axes. And let me label, 1, 2, 3, -1, -2, -3, and then up 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5. I will also label my axes X and Y. All right. So how do we plot that point? First thing we have to do is move to the left 2, right? Because the X is -2. So X being -2 actually puts me right there. But then I have to move whatever the Y is. And the Y here says to do what? 5 units up, because positive is up. So I go up to 5, and right there I will draw a dot. And that dot right there is the point that represents -2, 5. Let's do another one to the side here. How about 3, 0? So that means you always, I forgot to mention this, you always start at the origin. Okay, that's why we call it the origin. You always start at the origin, and from there, what am I going to do? Which over meaning to the right 3, right? Because it's a positive 3, that means you go to the right 3. So I go to the right 3, and then do I do anything after that? No. Because Y is 0, that means don't go up or down, just stay there. So I'm just going to draw a dot here. And I could keep going, right, through this, plotting points. Do y'all think y'all can handle that? Hopefully. Okay. What are some other things I want to point out? Something important and subtle, but important for where we're headed with this. I'm going to bring up a new graph, all right? I won't be as thorough with this one. But let's say I wanted to plot the point in this example. I told you to plot, I'm going to do it here on the right. Plot the point 5, 350. What's going to be a problem, or what's kind of trouble here? Nobody knows, nobody cares. What's the issue? 350. Seriously, am I going to have to count 350? So that's why I'm bringing this example up. Watch, here's what I'm going to do. I know I need to, for the X coordinate, right, for the X, I need to move which way? Right 5. Well, I can do that. I can go 1, 2, 3, 4, 5. There's 5, fine. But to go up 350, I'd be off the page, right? Way out there. So what you can do is you can what's called scale your axes. So even though left and right, each one of those dashes represents how much? Each one of those dashes is how much? 1. When you go up and down now, your dashes don't need to be equal to 1. Each one doesn't have to be 1. You can change it. You change it to 50. So what if I say 1 dash up is 50, then 2 dashes would be 100, right? 3 dashes 150, then 200, then 250, then 300, then 350. Do you see that? You are allowed to do that. Your X, the dashes that you have, your scale on your X-axis does not have to match your scale on the Y-axis. What you can't do is this, though. You see my X-axis over there? I can't call this over here -50. You see where I put the -50 in the red? So I can't say to the right they're each 1, but to the left they're each 10. On the axis, each dash has to be the same. Okay? So that's not allowed. If I do it this way, then I go to the right 5, I go up my 350, and I put my dot there, and I'm done. Now, another way you could have done this, just so you can see it, I could have done this. I mean, there's so many different answers that would be correct here. I could have done, no, hold on, let's do it this way. Okay, look at that right there. I could have done my axes like this. Then on the x-axis, each one of those dashes is how much? 5, right? Because you have to count out here 5, 10, 15. So each one of those is 5. And let's say I'm still trying to plot that point, 5, 350. Then where's 350? Well, wouldn't you say right between 200 and 400 is 300? Then halfway between that and the 400 would be 350, wouldn't it? So I could go out to the right 5 and up 350 would be about there. Y'all see that? Now this one is probably not as good as the one we had before, but it still illustrates the point, and you're there. The reason why this is important is because in a little while we'll be graphing more than one point, and so we may not be able to have the choice of our scaling as flexible as we did in the previous example. Like, oh, we just said, okay, 350 was very top, 5 was very far right, and we were done. If you have more than one point, you have to pick the best axis that gets both points on there at the same time. So we'll see as we move on. Okay, that's it for 3-1. All right, that's it. I just want you to be able to graph points, understand you can change your scales, and now we move on to what is a linear equation in 2 variables. I'll give you homework out of that in a second. Linear equations in 2 variables. So what is a linear equation in 2 variables? Well, here's an example, okay? Whoa, hey, don't do that. Example. 2x plus y equals 10. Now, what makes it an equation? What makes an equation? The equal sign, right? Okay. What makes it 2 variables? Well, the x and the y now, right? 2 different variables. What makes it linear? That's important. What makes it linear? What made our other equations linear? Yes, but what about the x and y? Go back to what we were doing like on your test. 4x plus 1. Exactly. Remember on the x, on the right there, that equation? Remember the x was to the first power? Like there was a little 1 up there, but we don't write it on the x? That's what makes an equation linear, is if the variables inside of it are all raised to the first power. If I change one of those, either the x or the y, if I square it or something like that, it's not linear anymore and it becomes a whole nightmare, and that's stuff you'll do later. Right now, we're just dealing with linear equations. So the fact that we have a power of 1 on each of those, which I'll put in red here, 1 here, 1 there, since the power on the x and the y are 1, it is linear. So we have to know that first, okay? That's what a linear equation in 2 variables looks like. Now I'm going to write it below this without all that highlighted junk all over it. I would like somebody to give me an example, if you can think about it, okay, mentally, try and figure out if you can determine an x and a y that would make this equation true. Somebody try and give me an x and a y that makes this true. 4 and what? 2? Do you all agree with that? Let's see. If I say x is 4 and y is 2, would it be true? Let's try it. It would be 2 times 4 plus 2 equals 10. Y'all see what I'm doing? Replacing the x with 4, the y with 2. That would be 8 plus 2 equals 10, and that's true. So I just found a solution to that, didn't I? But the solution was an x and a y. It's very different than this equation up here, top right. Somebody give me a solution to that equation. 2. Is there any other solution? This is what we were tested on, right? That's a problem like off the test. You would subtract 2 on both sides and you would get x is 2, wouldn't you? That is the only answer, right? That was our only answer. Now that we are dealing with these linear equations in 2 variables, we have an answer right now, don't we, to this equation? But is it the only one? So somebody else give me a different solution to that equation. 5 and 0. Do you all agree? Yes or no? Plug them in. 2 times 5 plus 0, does that equal 10? Yes. So 4, 2 works. 5, 0. Are there any more? -2 and what? 14. Yes, that would work. Is that a very natural selection? No, but it works, right? -2 and 14. Do you all agree that that works? Plug it in. 2 times -2 plus 14, does that equal 10? Yes? Okay. Now, we could keep doing this and finding answers. Guess how many there are? Any guess? How many answers we'll have? Infinitely many, okay? We could spend the rest of our lives, literally, each one of us could spend the rest of our lives finding answers to this, and we would die, and we still wouldn't have all the answers. Because there are that many. There's an infinite number of them. So how do I answer? I mean, it can't just be anything, right? I mean, there are some things that don't work, right? Like, what about 0, 0? Does 0, 0 work? No. So I'm not saying anything works. I'm just saying that there are answers, but they're all like, there's an infinite number of them, so I can't actually write them down, can I? I can start listing them, but then my list, would just keep going off the page. So the best way to actually write down the answers is to plot the answers as points on a graph in R2. So what I'd like us to do is I'd like to take the answers we just got. I'd like for us to plot those. We had 3 answers, right? Let's plot those in R2 on the next page. So we had 4, 2, 5, 0, and -2, 14. The equation was 2x plus y equals 10. The solutions that we found were 4, 2, 5, 0, and the crazy one, -2, 14. Now, before I start drawing this, I'm going to think about my scale on my axes. What is the largest x value we have? Of all the points we're going to plot, what's the biggest x we have? 5, right? What's the smallest x we have? -2, right? So I need to make sure my x-axis covers from -2 to 5. I also need to make sure my y-axis covers from where to where? 0 to 14. So here's how I'm going to choose to do this. This is my choice. Yours might look a little different. I'm going to choose to go 5 units left and right. And each one of these is worth 1. So that means 5 would be out here on the right. And -5 would be out here. That's my x-axis. Now, up and down, I need to be able to go 14, right? Up. So maybe I'll count by 2s. Do that. 2, 4, 6, 8, 10, 12, 14. And I'll just label this one down here 2. You don't have to label each of the dashes, okay? Just enough that people know what their value is. Now, should I label down on the y-axis? I don't have to because none of my points go down, but I will. All right, let's plot these. The first one, 4, 2, and I think what I'll do is I'll assign a color to each of these. 4, 2, I'll do in blue. So I'm going to go to the right 4 and up 2. That's right there, isn't it? Be careful there because notice that I went to the right 4 and up 2 didn't mean go up 2 dashes, right? It meant go up to wherever 2 is, and we labeled 2 right there, didn't we? So that's 4, 2. The next one is 5, 0. Where's 5, 0? I'll do this one in green. 5, 0 means what? To the right 5, and then don't go up or down, just stay there. Okay, and then the last one, -2, 14 means to left 2 and up 14, right? Left 2 would be, here's -2, up 14 puts me up here, like that. Those are 3 of the infinite number of solutions we have. Now, this section was titled, this chapter is titled, Graphing Linear Equations in 2 Variables, right? If you look at those 3 dots, don't they appear to all line up? Linear meaning line. The answers, the solution to any linear equation in 2 variables, if you plot a bunch of the points, they all lie on a line. So if I just connect those 3 dots with a straight line, I will have a way of visualizing all the answers. So I'm going to now connect these with a line. It lines up pretty good. If it doesn't cross through one of your dots, you can do this. You can just make your dot bigger like that. Kind of cheat a little bit. Now, what's the value of having this? I mean, why is this good to have this visual representation? Well, because what I can tell you right now, just by looking at this, I can tell you some things that are definitely not solutions, right? How about, without even doing any work, -2, -2? Is that an answer? No. Why? Where's -2, -2? To the left 2, down 2. It's over here, right? In the third quadrant. In fact, will any number out of any point out of the third quadrant work? No. So even though I can't list out all the answers, and even though I don't know exactly what each one of those is, I could find it if I had to. Like I could start looking and try different values. Does that kind of make sense? Okay. So that's the basic idea behind what a linear equation, two variables is, and what its solution looks like. It looks like a line. Okay. Let's graph the solutions to 5. I'm going to say negative 5x minus 2y equals negative, or I'll make it positive 10. All right, now take a look at this real quick. Can you just look at that and tell me what some answers are? I mean, it's a little harder than the last one, isn't it? A little more challenging? Would you agree? I mean, you probably could, given enough time, you probably could come up with some answers. Like, would negative 2, 0 work? Negative 2, 0 would work? But we have to have a better way, right? I mean, there has to be a more efficient way than just me looking and trying to guess, right? And we do have a more efficient way. And that's what we're building up to. But I want to show you our first way of doing it, okay? This is going to be our first kind of standard cookie cutter way of trying to graph the solutions to a linear equation like this. What we're going to do is we're going to find what's called the x-intercept. Now, what is the x-intercept? It's where the line hits the x-axis. So take a quick step back for a second. This is a linear equation in two variables, isn't it? Linear equation in two variables? We know, because it's a linear equation in two variables, we know that the solutions to this becomes a line if we try and draw it. If I draw a line, if I have the x and y axis R2 there, and I draw a line, no matter how I draw the line, I should cross the x-axis somewhere, right? Unless I draw a horizontal line, but that's one special case, and we'll deal with it in a little while. But every one of these hits somewhere on the x-axis, doesn't it? So I would like to try and draw this, or try and find that special point, which we call the x-intercept, where it hits the x-axis. So here's how I'm going to do it. Notice that when you're on the x-axis, any of these points that I just drew right here, if I were to ask you for their coordinates, in other words, the x and y, okay, give me the x and y for all those points. What are all the y's? 0, right? On any of those points, the y is 0. Any of them. So if you're on the x-axis, your y is 0, isn't it? So in order to find an x-intercept, what we do is we go up to the equation and we replace y with 0. That's the standard way of doing it. We say, okay, I know if I'm going to hit the x-axis, y has to be 0. Let y be 0. So I will now write underneath this, let y be 0, comma, now you solve for x. So go up to that equation we just had, negative 5x minus 2. Now I replace y with 0. What happens if I replace y with 0? It kills off that negative 2, doesn't it? And you get negative 5x equals 10. Can anybody tell me what type of equation that is? Linear equation, one variable, and we just had a test on that, didn't we? How do you solve that? In this case, all we need to do is what? Divide by negative 5, right? And we're there. So x is what? -2. So that gives me the x and the y, right, for the point that solves that equation. What was the x we just said? -2. And what was the y that we plugged in? 0. So this is a point on my line. In fact, it's called the x-intercept. It's the point -2, 0. Is that enough? Just finding that one point, is that enough for you to be able to go up there and draw the line now? How many points do you think you need to draw a line? 2, right? If there's a line out there and I only have 1 point on it, that's not enough for me to know where it is. If you give me 2 points on a line, then I can draw a straight line right through them. So we need one more point. So how do you think we are going to get the next point? If -2 is x, we know, though, we're going to get 0 out, right? Yes, the opposite way, exactly. We just found the x-intercept, right? How about trying to find where it hits the y-axis? How about trying to find these points here, where our line might hit the y? If I draw a line that goes through there, what do all those points have in common? What do all their x-coordinates have to be? 0. Right? For any of those points, x is 0. So to find the y-intercept, I'm saying y dash int is going to represent y-intercept from now on, okay? And x dash int will be x-intercept. To do this, we let what be what? Let x be 0, and then you solve for what? For y. So I write down the equation again, which was way up here. -5, and then x we're replacing with 0. Was it -2y? Okay, -2y equals 10. So when I replace my x with 0 there, it kills off the -5. All I'm left with is what? -2y equals 10. Now that's a linear equation in one variable again, right? So we can get an answer here. Divide both sides by -2, you get y is -5. Which gives me a point. Now be careful here with this point. I can't go down, or can't scroll that up. I'll move it over. What is the point then? What's the x and what's the y? What did we plug in for x in this problem? 0, right? So this is 0, and then what y came out of it? -5. So this is another point on your line. The first one we found was called the x-intercept. The one we just found is called the y-intercept. So now I'm ready to graph it. So I'm going to have to start a new page. The 2 points I'm trying to plot, well, let me write the equation first. It was -5x minus 2y equals 10. That's what I'm trying to graph, that equation. I found it was -2, 0, right? And it was 0, -5. Those are my 2 points. So now we graph those. I'm choosing my scale right now, kind of thinking about this as I do it. I know I'm going to need to go left and right. I have to go -2, right? Up and down, I've got to be able to go down 5. So that's the way I'm choosing my scales on my axes. So the first point is -2, 0. That's here. The next point is 0, -5 is here. What happens on a test or a quiz if you get those mixed up? It's wrong. Okay, it's wrong. Okay, now once you have 2 points, you just draw a line through the 2. And you'll be done. Damn, no, it was looking better. It's not bad. Good enough. Okay, today's quiz is going to be you doing one of these. All right? And we're going to try something different today. You're going to do it on your own. You can use your notes that you just wrote down, but no book, just your notes. Okay? So that means I want you doing your own work. I don't want you looking off your neighbor. I want you to see if you can figure out this problem I'm about to put on the board on your own. By the way, what we just did is we graphed a linear equation, 2 variables, using what was called the intercept method. We found the x-intercept and y-intercept, 2 points, we drew a line. That's what you're going to do on this one. So as your quiz, make sure you put your name, put today's date, which is the 12th, and then here's the problem. It's only going to be one problem. Graph -4x plus 6y equals -12 using intercept method. In other words, find x-intercept and y-intercept. Your homework, page 213, two through 7, 9 through 17 odd, 18 through 25 all. Make sure you do that homework for next class, all right? In other words, like I may just give you a quiz at the beginning of class next time. I got that on video and I'm recording what I just said, so I'll go back and I'll look at that and I'll say, oh yeah, I need to give them a quiz.